Hi, encryption is not just for programmers. I am Da, and these days I have been deep in thought, constantly pondering how to integrate AI with Web3. Accidentally, I discovered the GPT store and utilized this GPTs to develop my own application that can automatically identify Solidity code vulnerabilities, a GPT's application. This means it can identify vulnerabilities in our Web3 project codes and can even generate security audit reports in the style of well-known auditing organizations like scythe and Slowmist. It also helps in analyzing some project codes to achieve the purpose of learning and pre-assessment for investment research. We know that if you want to engage well-known auditing institutions like scythe and Slowmist for auditing your project codes, it can be very expensive. They often charge based on the number of lines. A project could cost tens to hundreds of thousands of dollars in audit fees, and during a bull market, the waiting time could be a month or even longer. However, I've found that many small project teams and even some users who are researching a project might not understand the project's logic and wish to see more details at the code level. At this time, we can use Web3 Panda Audit. Thanks to ChatGPT-4, the auditing speed and quality of Web3 Panda Audit are very high. Moreover, I used over 300 lines of tag explanations to standardize and process the AI's output. It automatically scans for dozens of common vulnerabilities and standards, such as reentrancy attacks, call attacks, etc. Without further ado, let me show you a demonstration of the application. Since our AI application is based on GPTs, you need to have GPT-4 access. I will make a separate video on how to activate this access later. Remember to follow our channel if you haven't clicked follow yet. The application is called Web3 Panda Audit. Initially, I plan to name it Web3 Tukou Heyue Shenji, which is straightforward, but considering that most GPT users are foreigners, I decided to use an English name. However, this doesn't affect your output results. As long as you speak to it in Chinese, it will reply in Chinese. At the bottom, there are 4 buttons, left for Chinese and right for English, with the same content. You can click to say, "Hey, please help me make a smart contract audit report." Then the reply I received was to copy the code that needs auditing into the chat window. I pasted a Tukou project code I found on a newly released list a couple of days ago, pressed enter, and got a response. The first step is called Preliminary Contract Analysis. It displays the compilation version of the smart contract and the name of the main contract, along with a brief introduction to the functions of the contract, including whether it is an ERC-20 contract and if it has other special features. For example, it also mentioned role access control, a linear time lock function, voting, and proxy voting features, etc. I won't go into details here. In the end, it asks if there's anything unclear. If you have questions, you can ask and it will answer. If not, enter next step or continue to proceed to the next section. We click continue and press enter. The next step is the elimination of contract vulnerabilities. It will display all function names and the status of the vulnerabilities. We see several function names here, showing a state of excessive permissions, among other issues like logic problems. There's quite a lot of content here. You can click to continue generating or manually write to continue the audit report generation. It explains the categories of vulnerabilities. Besides excessive permissions, there are logic vulnerabilities. It also provides a brief introduction, saying that excessive power indicates that a function might allow excessive control, changes, and states, potentially violating the principle of decentralization, indicating that the administrator's permissions are too large. As for logic problems, it refers to logical errors or potential logical errors in the contract that could lead to unexpected behavior. Let's click continue to see the detailed analysis report. The first vulnerability is excessive permissions, including functions 1, 2, 3, 4, 5 and many others. Once the detailed analysis report on this vulnerability is complete, it categorizes the vulnerability, including which functions have such vulnerabilities. It also provides a recommendation for modification, suggesting the use of multi-signatures or time locks to control the excessive permissions of administrators. Multi-signature refers to wallets like Gnosis Safe and other multi-signature wallets. If you're not familiar with this, you can watch our previous videos where it's been mentioned. Regarding the second vulnerability, it's a logic problem. It describes that these 2 functions might have a logical error. For example, one function, when updating the user's locked balance, did not consider the case of repeated calls, and the other, delegate by says, might encounter signature replay attacks when handling delegated voting. The entire report is roughly like this. If you don't understand some functions, like I randomly copy-pasted this function, you can ask what its logic is and if it can be explained. You can ask it to help analyze the function named update its features, logic, etc., and see what it says. Alright, it has written everything here. The function named update translates to update batch balance. It says here about initializing or updating the locked balance of specific investors at different investment stages. Below is a detailed analysis of the logic of this function. The function contains 3 parameters, an account address representing the locked balance, the number of locked tokens, and a third parameter, a type, which is to input a type to distinguish the type of investor. The function logic includes 3 parts. The first is role verification. The function first checks whether the caller has used the timelock update load role, which I guess is an administrator's account. We might see this more clearly if we look at the code. The role verification here is actually line 974. The second verification is whether this RAIMT is greater than 0, to ensure that an invalid time lock amount is not set, which is line 975. Then it checks whether this beneficiary account was previously allocated an initial balance, to prevent duplicate allocations, which is lines 976 to 979. The next part is the update of the balance, which is lines 981 to 983. It mentions potential logical problems, such as if repeated calls are allowed, it could lead to the locked balance of the same account being inappropriately and incorrectly updated. These problems are potential, not that they will definitely occur. We can think about these potential issues and whether such situations might arise. The improvement suggestion here is to increase more checks on the account status of the beneficiary to ensure that there are no duplicate and incorrect balance updates. Essentially, it suggests adding another line below to check what it should equal and what it currently equals, and if they match, proceed to the next action. Where to get it? I believe many of you are eager to try it out after watching this demonstration. Don't worry, I will put the link to this GPT application in the sidebar of our DC community. Those interested can follow our channel, and I will send the portal address to you. Completely free? Since GPTs has not provided a profit segment for us developers, this application is currently completely free. If anyone wants to find me for manual auditing, learn Web3 project development, or even develop a GPTs application, you can come to our homepage and find our contact information.